Here we have AP calculus BC problem. Okay, let's go to the question. Given that y equals to 1/3 secant to the third power x negative secant x positive 3, find dy over dx. Here we have a function defined by y in terms of x, and we have to find the derivative, that is dy over dx. Okay, now let me take this stuff as it is. It is y equals to 1/3 times secant cube x negative secant x positive 3. Okay, now let me find derivative on both sides with respect to x. When I find derivative of this y with respect to x, I am getting dy over dx. And here, the secant cube x contains variable x. So we have to consider the whole stuff for the secant cube x as variable. So this variable is multiplied by the constant 1/3. When I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to get the derivative of the variable alone. Okay, when I find derivative of the secant cube x, first I have to do derivative for this exponent 3 using the power rule of derivative. That is, we have to bring this exponent 3 in front of the variable and subtract 1 from 3. Then I am getting 3 times secant. Okay, now I got this exponent in front of secant. Now we have to subtract 1 from this exponent. When I subtract 1 from 3, I am getting secant square x. Okay, now I have completed derivative only for this exponent 3. By chain rule, I have to further derivative for the base secant x. The derivative of the secant x is secant x times tangent x. Let me write the stuff over here. Okay, now we can take these negatives and as it is, and the derivative of this secant x is secant x times tangent x. Let me write it. And the derivative of this positive constant, I mean the constant positive 3 is 0. And so here this 3 will cancel out. Then I'm getting dy over dx equals to okay, now what we can do is we can write this one as it is, and we don't want to multiply the secant square x and secant x, because in our next step what we can do is we can factor out this one and this one, because we find secant x times tan x in both the terms. Okay, so let me write this one as it is. That is secant square x times secant x times tangent x negative secant x times tangent x. Okay, let me continue dy over dx. And now what we can do is we can factor this secant x tan x from these two terms. Let me do it. So let me factor this out. Okay, when secant x tan x is factored out, to get the stuff inside, what we have to do is I have to divide both the terms over here by the one I factored out. When I divide this first term by this secant x tan x, this secant x tan x will cancel out. Then I'll have just only secant square x over here. Negative. When I divide this one by the one I factor out, so this one will cancel. I'm just getting 1 over here. So let me continue. So dy over dx equals to secant x times tangent x. Okay, now let's consider the Pythagorean identity in trigonometry. That is secant square x negative tangent square x equals to 1. Okay, now let me add tangent square x to both sides. When I add tangent square x to both sides, let me finish adding. So this negative tangent square x, positive tangent square x will cancel out. Then I'm getting secant square x equals to 1 positive tangent square x. Now let me subtract 1 from both sides. When I subtract 1 from both sides, I'm getting secant square x negative 1 equals to tangent square x. Actually, this is a basic identity we have. It's a Pythagorean identity, secant square minus tangent square equals to 1. So now from this identity, we can solve for tangent square, that is equal to secant square negative 1. Now for this secant square x negative 1, what can we plug in? We can plug in tangent square x. Okay, let me plug in over here. For this one, let me plug in tangent square x. Let me continue over here. Then I'm getting dy over dx equals to secant x times, when I multiply this tangent x and tangent square x, I am getting tangent cube x. Then we get dy over dx equals to, let me write this tangent cube x at first. Then I am getting tangent cube x times, we can write this secant x now. Okay, now for this given function, I got dy over dx, that is the derivative of y with respect to x. Its result is tan cube x times secant x. We find this stuff exactly in answer choice D. The correct answer choice for this question is D.